Listen, you're paying for Claude. You're trying to be careful with your prompts, but you still hit your usage limits anyway. So you try local AI like everyone in the comments told you to, and the local model spits out messy code that does not even work. Now you are stuck again. Listen, come closer. Your Claude limits aren't exactly a model problem. They're mostly a planning problem. Today, we're going to fix both on camera by building a top-down survival game with Gemma 4 model family. My name is Daniel Jindeo, and I used to run AI info business that questioned my morale every single day, and eventually I had to quit. Now I'm just giving away everything I know about AI for completely free. There's no gatekeeping. You can join my free community newsletter to get as much value as possible. All I'm asking for is just maybe consider commenting down below. Okay, so think about it. You hit Claude limit, you go local because the comments told you to, the local model spits out garbage, and now you just blame the model. But here's what most people miss here. I mean, the model size obviously matter, but local models do not fail because they are like useless. They fail because the plan you handed them is full of gaps. Same goes for Claude, same goes for Codex, same goes for any models. The model is just a worker. The plan is the blueprint. And if the blueprint is bad, the worker builds bad stuff. Doesn't matter how smart the worker is. So today, I'm gonna show you a workflow where you barely hit Claude limits, and it's the opposite of what most people are telling you online. Let's think of it like building a house. You don't just show up to a construction site with a vibe and a hammer. You start with an architect. The architect figures out what you actually want, where the load-bearing walls go, what's gonna break in 5 years. That's why architects are expensive as hog, right? But you don't skip them, because skipping them is gonna cost 10 times more later, possibly. Then you have the trades, the framers, the electricians, the plumbers. They show up with the blueprint and they execute on it. They don't just redesign the whole thing, the house. They build what's already drawn. They are cheaper, they're faster, they're only as good as the plan handed to them. And then there's you. You are the general contractor on site. You're not swimming hammers, you're not drafting blueprints, you're reading the plan, handing the trades one task at a time and verifying each one before moving on. So in our world, in the AI space, the architect is the frontier model like Claude or Codex. The trades are the execution model like Gemma 4. And you are still the GC, general contractor. The job site still does not run itself. That's the obvious part here. Now, here's what nobody's telling you about how to actually wire this up. Here's the workflow. It's 4 stages. Stage 1, you sit down with the architect first, which is Claude or Codex in our case. You let it interview you, not the other way around. The architect asks you questions until both of you know exactly what you're building. This is the part everyone mostly skip because they just want the outcome right away. But this is also where you save the most tokens later. And there's stage 2. The architect produces the blueprint, the build plan, architecture plan, the architecture document, the list of tasks, each task small enough that a contractor can finish it in one go. And there's stage 3. You hand the build plan to the contractor, which is the execution model. It could be a local Gemma 4 on Ollama cloud. You know, same workflow either way. The contractor does one task, you verify, then you hand them the next task. And there's stage 4, last step. When the contractor gets stuck, you escalate that back to the architect. You switch the model, ask Claude to figure it out, and hand that answer back to the contractor. That is usually what the loop looks like. Architect, blueprint, contractor, and escalate. Now I tried this on my own MacBook first. It's M2 Pro second-handed 16 gigs of RAM memory, and I want to walk you through what actually happened because most videos lie about this part. First attempt, I ran Gemma 4 adds 4 billion parameters locally, which is the small Gemma 4 model. I set the context window to 32,000 tokens, which is the minimum the documents say Claude Code needs. I plugged it in, sent my first prompt, and it came back saying I need more information. No matter what I asked, generic response, I need more information is what I got. So here's what was actually happening. Claude Code does not just send your prompts to the model. It sends a giant system prompt with tool definitions, instructions, the whole agent setup. You know, that alone is 50 to 65,000 tokens before your actual question, right? So a 32,000 context window cannot even see the full prompt. The model is just guessing because it never received the instruction. That's why it was saying, I need more information. So in plain English, the contractor showed up to the site with a blueprint that was cut in half. They asked for more pages. That's the error right there. So this time I bumped the context window up to 128,000 tokens. Now the model can see the full prompt. No more, I need more information garbage. It actually reads what I sent it. But now we have a different problem. problem. The model is just too small to actually run a full coding workflow. It adds 4 billion parameters. Generic response does not follow the build plan. It quits halfway through a task. So I had a perfect blueprint. The contractor could now read it, but the contractor just didn't have the skills to perform, execute. Now, this is the part most local AI videos hide. Big context window does not equal capable model. What you need is both. So this time I switched to Gemma 4 31 billion dense model, which is the biggest, most capable Gemma 4 model out there. Way too big for my 16 gig MacBook, but I didn't run it on my MacBook, right? Because I couldn't. I ran it through Ollama Cloud. There's two comments that I ran it with. That's it. Ollama sign in, Ollama launch Claude -- model, Gemma 4 31B - cloud. That's it, done. Claude Code talks to Ollama. Now then Ollama routes it back to Gemma 4 31 billion running on their cloud GPUs. Same workflow as local, just hosted somewhere with more horsepower. I know you don't like it, but please bear with me. And here's the kicker. Ollama Cloud has a free tier. They recently made it free with usage limits, sure, but the testing and the light bills, it'll cover what you need. Mine covered it, so I didn't pay anything for this video. So the realistic path for most people watching this is open weight model, no Anthropic API key, no $5,000 rig in your closet. You can just use Ollama Cloud. That's the actual answer if you don't have the right device. So which Gemma 4 should you run? There's a quick rule. If you have 16 gigs of RAM, like me, run Gemma 4 31 billion model on Ollama's cloud free tier for any agentic coding work. You don't bother with the small models on your laptop. They run, but they just can't do the job properly. If you have 32 gigs, you can run the 26 billion models locally for some workload, but the 31 billion cloud is just still the safer bet. If you have 64 gigs or more, you can run the 31 billion locally and it'll be fine relatively. But the cloud free tier is just cheaper for most use cases. It's free, guys, obviously. So pick by your hardware, not by the hype. And honestly, Ollama cloud free tier covers 90% of viewers watching this, right? Okay, back to the workflow. The most important part is the interview process. This is where you let the architect, which is Claude in our case, or Codex, ask you questions until both of you actually understand what you're building. Not just like build me a top-down shooter. That's the vibe mode, not a plan. I mean, the architect drilling you on player movement, enemy type, scoring, scaling, edge cases, file structure, all of it. I gave Claude one sentences are basically, I want to build a vampire survivor style, top-down shooter in vanilla HTML and JavaScript. And Claude came back with 20 plus questions like movement scheme, enemy variety, how does difficulty scale, scoring, persistence, state machine, polish features, etc. Each answer logged one piece of the build. It took me about 20 to 25 minutes of the interview. Output was 7 markdown files, product brief, user stories, architecture plan, build plan, local versus cloud split. Now the contractor does not get any of those right away. The contractor gets the build plan only, which divided into 15 tasks, each one small enough to finish it in one Claude Code turn. And here's what really surprised me. You know, I had the perfect plan. I had the capable model. That's what I thought. So I figured I'd just say to Claude Code, hey, self-verify your tests until all 15 tasks are done. Why don't you just come back to me when you are finished? Walk away, just get a coffee. However, that did not work twice. The 31 billion model quit mid-task. Once it stopped after task 3 and once it stopped after task 5. There's no error, just stop literally. And my take on this is even with a great plan and a capable model, you are still the dispatcher. There's no autonomous job site for local model yet, I think. The contractor needs the general contractor there to hand them the next task and verify the last one. Just, that's a safer bet for me. So I dropped the autonomous loop for this specific model and I just went task by task. To task 1, stop verify. To task 2, stop verify, right? Just proceed every step of the way. So here's what task by task actually look like. I opened Claude Code with Gemma 4 31 billion cloud. I drop the build plan in and I say read the build plan, empty document, implement task 1 only, stop and wait. And as you might have guessed, Gemma reads the spec, writes the code, stops, I run the game, I verify if it looks right, cool, next stop, proceed. However, the catch here is this took obviously longer than just letting the model loose, way much longer. But the build came out very clean. There's no correction, no throwing it out and starting over. Typically no mid-build refactors because the architecture had gaps, and honestly, I would really take slow and clean over fast and broken every single hour or every single day, right? Now, let me show you the proof here. It was same model, Gemma 4 31 billion parameters, same machine, same Claude Code setup, 2 different prompts. Prompt 1, which was really vague, League, right? Make me a Vampire Survivor clone in HTML and JavaScript with enemies and a player. And prompt number 2, the build plan we just walked through. Left side, vague prompt result. Hallucinated file structure, missed the auto fire entirely, and made of enemy behaviors that weren't asked for. And it was basically a very simple build and looked very simple garbage, right? Half the feature was missing, game barely runs, throw it out. And on the right side, which was a planned prompt result, working game, all 3 enemy types showing up at the right time, auto fire working, scoring persisting. Now there's a game over screen, right? Plays exactly like the specs that it would, which I use same model, same machine, just different plan, different universe. So here's the takeaway. 3 things make AI build works: a clear path, a capable model, and a human who stays in the driver's seat. Most people skip the plan, some try to skip the human, they both fail. The plan is the bigger lever. The model is the floor, and you are just still the dispatcher. You're dispatching it. So your Claude limits aren't exactly a model problem. They are a planning problem from what I've observed. And now you know the fix, because I hardly ever reach a limit even though I'm a power user. I use max plan all the time for all my LLMs, right? So if you want to build plan template I use, plus all the setup commands for every Gemma for size on the Mac, Windows, and Linux, plus the interview question template, plus the hardware sizing chart, and I put it all in a free PDF for you, which is linked in the description below. That PDF is the entire workflow in one place. You can just take it, use it, build something with it. Anyway, today was same model, different plan, different universe. That's what happened, right? That's for today. And if you want to see more, comment down below on what you want to see next. For the next video, I'm going to cover the Ralph Wiggum loop and how we can use this to make our lives better, because that is how our channel runs. You ask, I build, we all learn. See you in the next video.